Welcome students. In this video, we will discuss some questions based on number system, right? How to convert a number from one base to any other base. I will discuss from the fundamental level to the top level. For this, you have this PDF also. You may go through this passage and then we have some questions based on this. But before going to this passage, I will try to explain the fundamental of number system. See, what is the number system? For example, we have decimal number system. We are familiar with decimal number system. Why this is called the decimal number system? Because in decimal number system, we have total 10 digits, or we can say the decimal format, or we have 10 digits, right? We have total 10 digits, and those digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and after that, there will be combination of these digits like 10. 10 is combination of 1 and 0. Similarly, we have other number system also. For example, the binary number system, which our computer understand mostly. The binary number system. In this, we have only two digits, that is the 0 and 1. Then we will have may have an octal number system in which total 8 digits are possible. In binary, total 2 digits are possible. In octal, total 8 digits are possible. And those are 0, 1, 2, 3, 4, 5, 6, and 7. You may count, these are 7. After this, we may have a hexadecimal number system. In hexadecimal, we have total 16 digits, right? And those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And after that, we cannot write 10. In place of writing 10, we write A, B, C, D, E, and F. This A is equivalent to 10, B is equivalent to 11, C is 12, D is 13, E is 14, and F is 15. These are total 16 in numbers because we have started from the 0, right? So these are some basic number system which our computer can understand, right? And we may have some other number system also. One more thing we should take care that, see, binary number system in which total digits, I can write the total digits in this binary number system are 2. For octal, this is 8. For hexadecimal, the total number of digits are 16. So there are two kinds of number system, especially. The first number system in which the total number of digits will follow the format of 2 raised to power n. Right? See, this 2 can be written as 2 raised to power 1. This 8 can be written as 2 raised to power 3. This 16 can be written as 2 raised to power 4. Right? So these are the number system whose number of possible digits are in the form of 2 raised to power n. And what is this n? This n is the number of bits that it need to represent those digits. For example, to represent these two digits 0 and 1, I need only one bit. So I need only one bit, that is 2 raised to power 1. 0 and 1, it will be represented. For octal, we need 3 bits, right? We need 3 bits to represent any number in octal number system. Similarly, for hexadecimal, we need 4 bits to represent any number in hexadecimal number system, right? Okay. So apart from this, we can have other number system also for in which the total number of digits are not in the form of 2 raised to power n. For example, this decimal number system itself. See, total 10 digits. It cannot be represented in 2 raised to power any integer, right? 2 raised to power any integer. You cannot have any integer such that it will be equals to 10. So you cannot have any integer n. So broadly, we will have two kind of number system. One is the decimal number system, and another is the those number system in which the number of bits or the number of digits follows some specific rule, and the rule is 2 raised to power n. So I can represent in this way. If I write number system, so it may have two possible categories. The first one is the decimal number system, right? The other one will have a system which follow 2 raised to power n rule, right? For example, it may have the binary, it may have the octal, it may have the hexadecimal. For non, uh, for this category in which this 2 raised to power n rule is not following, we may have the decimal number system, we may have the base 7 system. Any system can be possible. Base 7 system, right? We may have base base 5 number system like this. Now, the question is how to convert from any number system to other number system. So the first rule I am going to explain for this one. If you want to convert any number from binary to octal or octal to hexadecimal, hexadecimal to binary, it means if you want to convert any one number system to other number system from the same group, it means from the 2 raised to power n rule, the rule is very, very simple. See, suppose I have binary number 0 1 1 0 1 1 0 1 1 1 1 0 like this. Suppose we have this binary number and we want to write, see, this is written in terms of binary, so I should write as base 2. Suppose I want to write in base 8, it means I want to write in octal number system. So the concept is very simple. Since for octal number system we need 3 bits, I have already explained. For octal number system you need 3 bits. So what you for this, what we have to do, you have to start grouping of 3 digits from right side. We have to start grouping of 3 bits from the right side. So this one, and this one. And if this last digit is not in a 3 bits, you can pad it with its 0. So you can write here 0 0. So, okay, for octal number system, see, we should start with the 0 0 0, then next 0 0 1, 0, wait, yeah, 0 0 2, and we know in binary system, basically we for 3 bits we can count as 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and 1 1 1. It is decimally 0, it is decimally 1, it is decimally 2, similarly for 3, for 4, for 5, for 6, and this is for 7. Now we can simply write, see, 1 1 0. See, 1 1 0 is corresponds to 6. So we should write 6. See, the next is 0 1 1. See, 0 1 1, this one. That is, it should be 3. Next, 0 1 1, again, it should be 3. Next, 1 1 1, that is the 7. And the last one is 0. So this is the octal equivalent of this binary number system. Similarly, if you want to write for the hexadecimal number system, suppose I'm taking the same number 0 1 1 1 0 1 1 0 1 1 1 1 0. This is in base 2. I want to write in hexadecimal number system. So again, the concept is same and similar. You have to start grouping of 4 bits. Why 4 bits? Because the hexadecimal can be represented with the 4 bits. So you have to start your grouping of bits from right side in a number of 4. So please see the first group of 4 bits, then next this one, then this one, and at the end, if you don't have the 4 bits, you can pad it with required number of zeros. So now you have to write the hexadecimal equivalent of all these 4 bits. For that, you should know the hexadecimal number system for 4 bits. See, 0 0 0, 0 0 0 1, 0 0 1 0, 0 0 1 1, 0 1 0 0, 0 1 0 1, 0 1 1 0, 0 1 1 1, 1 0 0 0, 1 0 0 1, 1 0 1 0, 1 0 1 1, and then 1 1 0 0, 1 1 0 1. Wait. Then 1 1 1 0, and at the end 1 1 1. You may count, these are 16, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so now please see this 1 1 1 0 is, see, we have another way. Okay, wait, this is the 0, this is the 1, this is the 2, this is the 3 4 5 6 7, 8, 9, and this is not 10. This is A, this is B, this is C, this is D, this is E, and this is F. Now you have to see this 1110 is what? We have other way to find this equivalent. We don't write all these directly and each and every time. See, 1110 is here. This is equivalent to E. So you should write E. Next, 1101. 1101. See this, that is a C. So you should write C. And next, 1110. 1110. Again E. So you should write E. And at the end, you have 0. So you should write 0. So this is the equivalent of this binary number. So I hope you are understanding how to convert from binary to octal or octal to binary. Suppose we have a octal number. Suppose 728 in, no, we cannot write 728 in octal, because in octal number system any digit should be less than or equals to 7, not 8 is allowed. So suppose we have 723 in octal number system and you want to write in binary number system. So what we should do, we should convert each digit to its binary form. See, 3 can be represented as 011, this is 3, 2010, and 7111. So this is the binary number system for this 723. Now, if we want to convert from this 2 raised to power n base to any other base, okay, let me give you a mind map. Suppose you have this binary, this octal, this hexadecimal. Mostly these are used. And suppose we have base 7, base 5, or any other base other than 2 raised to power n form. This, and you have a base 10 in middle. Right? So see the mind map. These are interconvertible easily. You can easily convert binary to octal, octal to binary, right? Now, if you want to convert from these binary, octal, and decimal to any other base 7, base 5, base other than 2 raised to power n form, so you cannot convert it directly. First, you have to convert it into the base 10, and then it should be converted into the other base. This is written in our passage, right? If you have the format of 2 raised to power n, and if you want to convert it in any other base, so first you have to go to your base 10, then you have to convert it to the other base. Now the question is how to convert from base 10 to other base, right? For example, we have a number like 723 in base 10, and I want to convert it into, suppose, base 2 or base 5. So what we should do? We should divide the given number with the base 5. Like this is called the division method, division and remainder method. So please divide. So, okay. So question will be 144 and the remainder will be 3. So we should write 3 here. Now again, you have to divide with the 5. Remainder is 4. Again with the 5 times 3. Again with the 5. So one time the remainder will be 0, right? So, okay, one more time we can divide it with the 0 time and the remainder will be 1 itself. So now you have to write your answer from bottom to top. So its answer should be 10343 in this base 5. Similarly, you can convert it into the any other base. It means from binary to any other base. That's very simple. Binary to any the decimal to any other base, that's very simple. If you have to go from base 10 to any other base, you have to follow this rule. Even you can convert to base 2, base 8 also directly from base 10. Suppose we have to do 720 from base 10 to this base 2, so we have to follow the same rule. We should divide this 72 with the base 2, so it is the 36, the remainder should be 0. Again 2, right? 18, the remainder should be 0. 2, 9, the remainder should be 0. Then 2, 4 times, the remainder should be 1. 2, 2 times, the remainder should be 0. 2, 1 time, the remainder should be 0. And then again 2, 0 times, and the remainder should be 1. You have to follow this step until unless you got your question at 0. Now you have to read your answer in this way from bottom to top. So its answer should be 1001000 like this. So this should be answer. So from base 10 to any other base, that's very simple. from base 10, what we have confirmed, base 10 to any other base. Any other base. That's very simple. You have to follow this rule. Now, can we reach from any base to base 10? How we can reach from any base to base 10? Let us take a question. Suppose we have, okay, we should take the same question. This one. I'm taking this 10343 base 5. Now I want to write in base 10, right? So the rule is very simple. We have to follow the positional number system concept. See, this is the unit place. So its positional value is, see, you should multiply this 3 into 5 raised to power 0 plus next 4. See, this is the at 10th place. So it should be 5 raised to power 1 like this plus 3 into 5 raised to power 2 plus 0 into 5 raised to power 3 plus 1 into 5 raised to power 4. Okay, so we can simplify this. See, 5 raised to power 4 is what? 5 raised to power 4, that is the 25 into 25, that is the 625. And this is the 0. This is 5 square is 25. 25 3s are 75. Plus 4 5s are 20. Plus 3 into 1, that is the 3. So what we should get? This, if you add 625 plus 75, that is the 700 plus 23. Yes, we are getting 723. That was our previous data. You can verify. See, we have converted this 723 to this base 5, and now we have again converted back to base 10. So in conclusion, we have understood how to convert any base from any base. If you want to convert from any base to base 10, right? You have to multiply. I can write. We can multiply. We have to multiply with suitable positional value, right? As you can see here, like the first place, the unit place should be multiplied by 5 raised to power 0 because we have in base 5. If it is the base 8, so we have to multiply with the 8 raised to power 0. Okay, so in this mind map, I am writing multiply with the suitable positional value. If you are going from any base to base 10, if you are going from base 10 to any other base, you have to use your division and remainder method. Division and remainder, like this. These two examples we have discussed with the same concept, how to use the division and remainder method. And the last, this one, if you have to convert among the same data type, it means same number system, it means 2 raised to power n form, like binary to octal, octal to hexadecimal, hexadecimal to octal. You have to just see your grouping, the particular and the appropriate number of bits you have to take in your grouping, right? These are discussed in this passage, right? And we have some questions based on this one. So see, this video is going to be a little long, so you have to watch this in a very proper manner, otherwise you may get confused. Let's see some questions based on this. Okay, the first question is, what is the first step in converting from a base 2 raised to power n to other base? So they are saying if we have to convert from base 2 raised to power n to other base, it means, for example, base 5 or 9. So I have told you that first you have to go for base 10. Then you can go to any other base. So what should be the answer? See, first one saying convert directly using grouping. No. Convert to binary first. No. Convert to decimal. Yes, this is the correct. The second question. Why is it difficult to convert directly from base 2 raised to power n to a non 2 raised to power n base? Because there is no particular pattern of bits, right? It is not necessary that the base 7, base 9, like, see, first option, because they use the different digits. Yes, it may be because non 2 raised to power n bases do not use binary, because there is no simple positional system, because there is no, yes, there is no fixed digit grouping pattern, right? For non 2 raised to power n base, we cannot say how many bits it will need. It may be base 7, it may be base 9, it may be base 13, right? So this should be our answer. What method is used to convert a decimal number to a target base? I have discussed already. If you have to go from base 10 to any other system, right? we have to follow the division and remainder method, right? So the answer should be division and remainder method. What is the decimal equivalent of binary? See, now we have this binary number system 101101. This is in the binary, so we should write 2. And now we have to write the decimal number system. It means from any other number system to decimal, we are going in this direction. So for that, we have to use the multiplication with the positional number system. So see, this should be multiplied by 2 raised to power 0. This should be multiplied by 2 raised to power 1. This should be multiplied by 2 raised to power 2. This should be multiplied by 2 raised to power 3, right? This should be multiplied by 2 raised to power 4, and this should be multiplied by 2 raised to power 5. Okay, so let us see. So I can write 1 is 1 into 2 raised to power 5 plus 0 into 2 raised to power 4 plus 1 into 2 raised to power 3 plus 1 into 2 raised to power 2 plus 0 into 2 raised to power 1 plus 1 into 2 raised to power 0. So see, 2 raised to power 5 is 32. This is 0. This is 8 plus 4 plus 0 plus 1. So see, 32 plus 8, that is the 40, plus 5, that is the 45. So answer should be C, that is the 45. Let us see the next question. What is the base 7 representation of decimal number 45? See, now we have 45 in base 10 and we want this to convert in base 7. So we are going from base 10 to other base. So you have to use your division and remainder method. So 45 should be divided with the 7, right? So 6 times, remainder should be 3 here. Again, 7, and it should be divided in division by 0 times. The remainder should be 6. So now we have to write answer in this way from bottom to top. So it should be 63. Is there any option? Yes. First option, that is the 63. That should be our answer. You can verify it again. See, 73. So 63, base 7. I want to write in base 10. So you can do 3 into 7 raised to power 0 plus 6 into 7 raised to power 1. See, this is 42 plus 3, that is the 45. One more thing I can give you a general idea. See, if your base is reduced, see, if your base is going to be reduced, see, 10 to 7 base is going to reduce, it means number representation will be higher. See, if you compare 45 and 63, so 63 is greater than 45. If your base gets reduced, the number should be increased. See here, you are going 7 to 10, base is increasing, so the answer, the number is decreasing with respect to 63. If you compare, it is less, just like unit and the magnitude. If the unit is greater, the magnitude will be lesser, right? Please see the sixth one. Which of the following is not a base 2 raised to power n? So this is 2 raised to power 1. So it is okay. We have to find not. 4 is 2 raised to power 2. 8 is 2 raised to power 3. So yes, this is not in 2 raised to power n. So this should be our answer. Please see the seventh one. What is the result of converting hexadecimal 2f to base 5? Now see, 2f is in your base hexadecimal, and now we have to write in base 5. We are going from 2 raised to power n number system to any other number system which is a non 2 raised to power n base, right? This is a non 2 raised to power n base system. So according to this discussion, we have to go first base 10. We have to first convert it into the base 10. And to convert it into the base 10, you have to multiply with the proper positional values. So f into 16 raised to power 0, this plus 2 into 16 raised to power 1. See, this 2 into 16, that is a 32, plus f is 15. I have discussed in the beginning, f is equivalent to 15, you may see, and 16 raised to power 0 is 1, so it is 15. So 32 plus 15, that is 47. So this is 47 in base 10. Now I have to write this in base 5. So if you want to write from base 10 to 5, now you have to use the division and remainder method. So 47 should be divided by 5. I think 8 times. Yes. No, 9 times. It should be divided by 9 times. And the remainder should be 2. Again, 5, 1 time. The remainder is 4. Again, 5, 0 times. The remainder is 1. So we have to write in this way from bottom to top. So its answer should be 142. Let us check the options. Yes, B is the option, 142. So this should be our answer. So I hope you have understood the concept as well as these questions. See, I have tried my best to give you a concise and a quick uh, revision or concept of these kind of conversions. If you have any doubt, you can ask me in the comment section, right? I will try to give you answers as soon as possible. And if you like this discussion, please like this video, subscribe this channel. Thank you. Thanks for watching.